Hey, everyone! Welcome back to the channel. Today, we're diving into one of the most breathtaking and groundbreaking discoveries of our time: images of the early universe captured by the James Webb Space Telescope. The universe as we know it is vast and filled with mysteries, but thanks to Webb's incredible technology, we now have a window into the distant past, allowing us to explore galaxies formed billions of years ago. What do these new images reveal? How are they changing our understanding of the cosmos? Let's dive in and explore the wonders of the early universe together. Albert Einstein once suggested that we might never see the edge of the universe, but was he right? Now, with the powerful James Webb Space Telescope, scientists have spotted something extraordinary in the early universe that could support his theory. But what exactly are we seeing? Is it truly a void? Or could it be the very beginning of everything? Scientists may have discovered something shocking: a mysterious hole at the dawn of time that might finally prove Einstein's incredible ideas. Imagine this: over a century ago, astronomers began peering beyond the edges of our Milky Way. What they saw was mind-blowing. At first, they only saw faint, fuzzy patches of light. But soon they realized these weren't just clouds of gas, they were entire galaxies. The Andromeda Galaxy, along with the small and large Magellanic Clouds, were the first glimpses into a universe far larger than anyone had imagined. Then came a bigger shock. Countless more galaxies filled the cosmos, reshaping our understanding of the universe. It was discoveries like these that gave rise to revolutionary ideas: how galaxies evolve over time, and the mind-bending thought that the universe itself might be endless. Then, Edwin Hubble noticed something even more astonishing: distant galaxies were moving away from us, sparking the idea of an expanding universe. Not long after, a Belgian physicist named Georges Lemaitre proposed the theory of the Big Bang. All of this unfolded just after Albert Einstein introduced his groundbreaking ideas. And now, with the Webb Telescope's latest discovery, could we be on the verge of proving him right once again? Relativity. Many of the bold, theoretical predictions made by researchers in the early 1900s came true as new discoveries were made. Yet, there was one mystery that even Albert Einstein couldn't fully resolve. Did the universe have a beginning and an end? Although Einstein believed in the Big Bang theory, he was certain of one thing: no matter how advanced our telescopes became, we would never be able to see the true beginning or end of the universe. So, what does this have to do with the mysterious void that the James Webb Space Telescope recently found? And how did Einstein arrive at such a mind-bending conclusion? Einstein, one of the greatest physicists of the 20th century, made many predictions that still shape modern science. One of his most intriguing ideas was that we could never observe the exact moment the universe began. But why? He based this on two key insights. First, according to the Big Bang theory, the early universe was shrouded in darkness for a long time. There was no light. Scientists now call this period the cosmic dark ages. So, if there was no light, how could even the most powerful telescope, like binoculars for the cosmos, allow us to see into the past? Einstein's prediction still echoes through modern astronomy. And with every new discovery, like the void spotted by the Webb telescope, we come closer to understanding the universe, but also further from ever truly seeing its very beginning. Imagine a time when there was no light at all. How could we possibly study such an era? Fortunately, today we have some amazing tools like radio telescopes that don't see but instead hear the universe. However, there's a twist. Despite the name, the Big Bang wasn't a loud, explosive event. In fact, it was completely silent. Why? Because space itself didn't even exist yet. The Big Bang created space, so the concept of a loud explosions doesn't really apply. Radio telescopes detect waves, but not the kind of sound waves we can hear. Space doesn't carry sound well, and the interstellar medium only allows certain waves to pass through. With today's advanced technology, we can hear these distant waves, but they tell us something important. The beginning of the universe wasn't loud. It was eerily quiet. In the 1960s, scientists made a breakthrough discovery: cosmic background radiation, a kind of afterglow from the Big Bang. This radiation has given us a clearer picture of the universe's early days and provided a lot of evidence for the Big Bang itself. However, we've never been able to directly link the radio waves we detect today to the exact moment of the Big Bang. So while we've uncovered a lot about the universe's origins, Einstein's idea still holds true. We may never be able to truly see or hear the very beginning of the cosmos. Albert Einstein believed we might never see the true beginning or end of the universe for a fascinating reason. He thought that as the universe kept expanding, the starting point of it all would move farther and farther away, eventually drifting completely out of our sight. Plus, Einstein theorized that space itself could be curved, meaning the universe's starting point might be hidden behind a cosmic veil we could never pierce. Now imagine this scenario playing out again. Even with the most powerful telescopes, distant galaxies would only appear as blurry smudges. But today, we know something incredible. The universe is filled with millions of galaxies and galaxy clusters, and it's expanding at an astonishing rate. Yet, despite the vast gaps between these galaxies, our telescopes can still peer back in time 13.6 billion years, almost to the dawn of the universe itself. With the James Webb Space Telescope, we've already come so close to witnessing the Big Bang. But then, something unexpected happened. A strange, empty region was found. You may have heard that the JWST has discovered so many ancient galaxies, some even older than we thought possible, that they're challenging our understanding of the Big Bang. But did you know the JWST also uncovered something even more mysterious? A vast emptiness in space? The James Webb Space Telescope has uncovered a mysterious void that may lend support to Albert Einstein's theory that we can never truly see the absolute beginning of the universe. In the cosmos, there are strange regions known as absolute voids, areas so empty they seem to challenge our understanding of relativity. But how do these voids back up Einstein's ideas? Initially, scientists thought these vast emptinesses were silent witnesses to the Dark Ages, a time when there were few, if any, stars or galaxies. Some researchers believe this discovery at least confirms that this epoch existed. But then came the shock. What appeared to be darkness turned out to be a distant void, raising more questions than answers. We also know of closer gaps in the universe, which are already puzzling enough. But in the early universe, these voids seem scientifically impossible. They don't align with the idea of a uniform cosmos, a principle closely tied to the Big Bang and the theory of exponential growth. These voids are not only too vast, but also exhibit strange variations that contradict some fundamental concepts of our universe. While these gaps don't definitively prove Einstein's theory, the findings from the Webb telescope do seem to resonate with his perspective in another way. So far, it hasn't detected any signs of the universe's early formation. This silence might just reinforce the notion that the beginning is forever out of reach. When we look at images thought to represent the early universe, we see galaxies and structures that appear surprisingly similar to what we observe today. But could these gaps signify the very beginning of everything? What do singularities really mean in this context? This raises an intriguing question. Could a strange void have been the birthplace of the universe? While we can't definitively say that a void wasn't where it all began, we also must admit that the true origins of the universe remain shrouded in mystery. Nowadays, we tend to think of voids as empty expanses. However, we can't rule out the possibility that they harbor something we have yet to discover. Consider the concept of dark galaxies. Some scientists speculate that voids could be alternate realities, while others suggest they might be remnants from cosmic collisions in a multiverse scenario. There are even wild theories proposing that aliens could be darkening galaxies within these voids to siphon energy from them. It's clear that these enigmatic gaps spark the imagination, leading scientists to explore some truly outlandish ideas. What if our universe began in a vast, empty space? This notion gains traction simply because we cannot prove otherwise. The fundamental question of how matter came into existence is still open for debate. So what do we mean by singularities? As we've discussed, the universe is thought to have originated from nothing. But how could we even perceive that moment if it was truly the start of everything? A singularity is a point where the forces of nature are so densely compressed that our usual measurements of size and scale break down, rendering everything we understand ineffective. In essence, the deeper we probe into the universe's beginnings, the more questions we uncover and the more possibilities we explore. The mystery is far from solved, and the quest for answers continues. At the very beginning, everything we know was concentrated into a single point, a point of total equilibrium, filled with a fluctuation of possibilities. Then, at some unknown moment, something extraordinary happened. This stillness was shattered, and creation began. From this incredibly tiny dot emerged everything we see today, from the stars in the sky to the life on Earth, and even you and me. It's mind-boggling to think that such a minuscule speck of nothingness could hold the entire universe within it. One of science's greatest mysteries is understanding how this tiny dot contained the information for everything we know. Will we ever unlock the secrets behind this cosmic puzzle? Interestingly, these enigmatic points of no return are not limited to the dawn of the universe. They are also found in black holes, lurking in the centers of nearly every galaxy we observe. Scientists believe that black holes are the remnants left behind when massive stars explode. Yet, no one has ever ventured into the heart of a black hole, and as we've seen, our ability to explore the very beginning of the universe is extremely limited. Our current understanding relies on calculations that seemed logical until the James Webb Space Telescope revealed something unexpected. Its findings suggest that the universe may be much older than we previously thought, or that it behaves in ways our models couldn't predict. And speaking of mysteries, black holes remain one of the most puzzling phenomena in physics. Their very nature challenges everything we know about the universe, leaving us with more questions than answers. As we continue to explore, each revelation brings us one step closer to understanding the cosmos, but the journey is just beginning. The sheer size and density of black holes are astonishing, and because the forces within them likely stretch toward infinity, we may never be able to truly explore these mysterious singularities using conventional methods. Instead, we're pinning our hopes on the next generation of supercomputers, which we believe will have the intelligence to unravel the universe's deepest mysteries and reveal how everything is interconnected. To achieve this, scientists are harnessing the power of quanta, those tiny particles thought to contain all the information about the visible world at once. Meanwhile, innovative chip technologies are tapping into water's unique ability to store energy, leading to the creation of cutting-edge computing power that defies our traditional understanding. As we stand on the brink of this technological revolution, the potential to unlock the secrets of the universe feels closer than ever. Each breakthrough brings us a step nearer to understanding the fabric of reality and our place within it. The James Webb Space Telescope, or JWST, is the most powerful space telescope ever built, and its mission is nothing short of revolutionary. Launched in December 2021, Webb was designed to observe some of the oldest light in the universe, peering back over 13 billion years. This is no ordinary telescope. Its massive golden mirrors, along with advanced infrared capabilities, enable it to capture incredibly detailed images from deep space. With Webb, astronomers are now able to study the formation of the first stars and galaxies, shedding light on the origins of our universe. It's a giant leap forward from the Hubble Space Telescope, offering us an unprecedented look at cosmic history. The recent images released by JWST are nothing short of mind-blowing. These snapshots of the early universe take us back in time, to an era when the first galaxies were forming. What's truly remarkable is how detailed these images are showing us not just distant galaxies, but the very process of star formation within them. These images are helping scientists to understand how the universe evolved over billions of years, from a hot, dense state following the Big Bang to the complex and beautiful cosmos we see today. For the first time, we can witness what the universe looked like shortly after it began. One of the most exciting aspects of the new JWST images is the glimpse into some of the first galaxies ever formed. These ancient galaxies are faint and far away, making them difficult to detect with previous telescopes. But Webb's advanced infrared capabilities have allowed astronomers to identify them with stunning clarity. By studying these galaxies, we can start to answer some of the biggest questions in astrophysics. How did the first galaxies form, and what role did dark matter play in their development? These discoveries are not only fascinating but also crucial for our understanding of the universe's earliest stages. The images from JWST are providing valuable insights into the nature of dark matter and the structure of the universe. Dark matter is a mysterious substance that makes up about 85% of the universe's mass, but we still don't know exactly what it is. By observing how galaxies formed in the early universe, scientists can gain clues about how dark matter behaves and interacts with visible matter. This could be the key to unlocking one of the biggest mysteries in cosmology. The data from Webb is helping to refine our models of the universe's expansion and could potentially lead to groundbreaking new theories. The discoveries made by the James Webb Space Telescope are only the beginning. With its incredible power, Webb will continue to observe the most distant reaches of space, helping us to uncover new phenomena and solve age-old mysteries. From studying exoplanets to searching for signs of life in the universe, JWST is poised to revolutionize our understanding of the cosmos. As more data comes in, scientists are preparing for a new era of space exploration, one where we may finally answer questions that have puzzled humanity for millennia. The future of space exploration is brighter than ever, thanks to Webb. The James Webb Space Telescope, or JWST, is the most powerful space telescope ever built, and its mission is nothing short of revolutionary. Launched in December 2021, Webb was designed to observe some of the oldest light in the universe, peering back over 13 billion years. This is no ordinary telescope. Its massive golden mirrors, along with advanced infrared capabilities, enable it to capture incredibly detailed images from deep space. With Webb, astronomers are now able to study the formation of the first stars and galaxies, shedding light on the origins of our universe. It's a giant leap forward from the Hubble Space Telescope, offering us an unprecedented look at cosmic history. The recent images released by JWST are nothing short of mind-blowing. These snapshots of the early universe take us back in time to an era when the first galaxies were forming. What's truly remarkable is how detailed these images are showing us not just distant galaxies, but the very process of star formation within them. These images are helping scientists to understand how the universe evolved over billions of years, from a hot, dense state following the Big Bang to the complex and beautiful cosmos we see today. For the first time, we can witness what the universe looked like shortly after it began. One of the most exciting aspects of the new JWST images is the glimpse into some of the first galaxies ever formed. These ancient galaxies are faint and far away, making them difficult to detect with previous telescopes. But Webb's advanced infrared capabilities have allowed astronomers to identify them with stunning clarity. By studying these galaxies, we can start to answer some of the biggest questions in astrophysics. How did the first galaxies form, and what role did dark matter play in their development? These discoveries are not only fascinating, but also crucial for our understanding of the universe's earliest stages. The images from JWST are providing valuable insights into the nature of dark matter and the structure of the universe. Dark matter is a mysterious substance that makes up about 85% of the universe's mass, but we still don't know exactly what it is. By observing how galaxies formed in the early universe, scientists can gain clues about how dark matter behaves and interacts with visible matter. This could be the key to unlocking one of the biggest mysteries in cosmology. The data from Webb is helping to refine our models of the universe's expansion and could potentially lead to groundbreaking new theories. The discoveries made by the James Webb Space Telescope are only the beginning. With its incredible power, Webb will continue to observe the most distant reaches of space, helping us to uncover new phenomena and solve age-old mysteries. From studying exoplanets to searching for signs of life in the universe, JWST is poised to revolutionize our understanding of the cosmos. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.